there are two types of carbon compounds. So carbon compounds are divided into two, which are organic compounds and inorganic compounds. So what are organic compounds? Organic compounds are organic carbon compounds are basically compounds that are made out of carbon and something else such as hydrogen or nitrogen. And the main thing is that it comes from living things. So inorganic compounds, on the other hand, they are compounds that come from non-living things. So that is normally includes carbon dioxide and cyanides. Wait, I spelled cyanides wrong. And I forgot the other one, or carbonates. So yeah, cyanides of carbon, carbonates of carbon, and oxides of carbon like carbon dioxide, carbon monoxide. These are inorganic. While organic compounds are divided into two: hydrocarbons and non-hydrocarbons. So hydrocarbons contains carbon and hydrogen only, while non-hydrocarbons contain other stuff such as oxygen, nitrogen, phosphorus, and so on and so forth. Hydrocarbons can be divided further into saturated and non-saturated. So saturated hydrocarbons only have single bonds, while non-saturated hydrocarbons have double bonds or triple bonds. Yeah, that's the highest I can go. So, where do we get these hydrocarbons from? We get them from petroleum. So petroleum actually contains petroleum actually comes from dead plants and dead animals. Their waste has undergone a lot of processes for about 1,000,000 years, and then it becomes petroleum. So petroleum contains a lot of simple but also long chain carbon compounds. Okay, they're mostly I think it's hydrocarbons lah. So they have simple hydrocarbons and they also have long chain hydrocarbons. So to extract this hydrocarbons from petroleum, we need to do a few processes. So let me just look back and see what the first process is. Let me see if I missed out on anything. Okay, so the petroleum are in the ocean. They're found in the ocean, and as I said, they were made like millions of years to make petroleum. It took millions of years to make petroleum, and petroleum itself cannot be used for stuff. It needs to what we call it refining or oil refining. So the refining has two stages. Number one is fractional distillation, and the other one is cracking. So fractional distillation is heating up your petroleum to certain temperatures. Why do you want to do this? Because inside petroleum we have the simple carbons and the long chain hydrocarbons. So the main difference between these two is their boiling point. So for example, bitumen has a boiling point of 500 degrees Celsius, while petroleum has a boiling point of less than 40. So of course, when you heat it up to 50 degrees Celsius, only petroleum gas will actually become gas first, but bitumen will still be liquid. So that is fractional distillation. You want to separate the gases into the separate layers according to their boiling point and according to their boiling point. And the longer the carbon chain, the higher the boiling point. So most of the simpler carbon chains are at the very top of the, what's it called again? I forgot like the chamber, while the lower boiling points like bitumen or fuel oil, they are at the lower part of the chamber. So that's that. Next is cracking. If fractional distillation is trying to separate hydrocarbon and simple and complicated hydrocarbons, cracking is changing long chain to become simple. So long chain can become simple. So yeah, it's breaking down. And normally you want to you want to do this at a high temperature. and also with the presence of a catalyst. And the reason why you want to do this is because simpler hydrocarbons are more useful than long chain hydrocarbons. For example, I can use long chain hydrocarbons for road pavements. That's bitumen's function. But I can't use bitumen for everything. I can't use it for my cooking gas. I can't use it for my lubricating oil. I can't use it for my car fuel. I need to use something else. I need to use a simpler hydrocarbon. So this cracking method is to turn that bitumen into smaller hydrocarbons. And yeah, let me see what else there is. Yeah, basically, simpler hydrocarbons are more useful. The main reason why they're more useful is because of their boiling point. As I said, their boiling point and the combustion rate. Basically, smaller size hydrocarbons are easier to burn, so they're easier to be converted into energy. For example, car fuel is easier to burn than road pavement. Imagine if your road pavement can burn. I don't want to imagine that either. So yeah, I guess that's all for the. Oh wait, UEC is different about the cracking. UEC cracking has two separate methods. One is thermal cracking and the other one is chemical cracking. I forgot what it's called again. But thermal cracking is with temperature, while chemical cracking is with a catalyst but also a high temperature, but not as high as thermal cracking. So yeah, okay. But remember, as I said, petroleum is millions of years to process. So that means that it is a non-renewable compound. So what do non-renewable source of fuel? So how do we get how do we replace this petroleum in the future? There's a new solution called biomass, which is basically a sun converting like dead bodies of plants and animals to become stuff, and these can turn into hydrocarbons, so they are renewable. So yeah, they are renewable. But yeah, I guess that's